Can you hear me?
Yes. Yes.
Okay.
Namaste. Good afternoon.
Yes. Namaste, Dr. Paudyal. Okay. Is Mr. Somyant there?
Yes, good afternoon, sir. We are here.
Okay. Shall we start?
Yes, we can start. We should start now.
Okay. So all of you can hear me.
Yeah, we
Uh,
can hear. We can
okay.
hear. We can see you.
All right. Great. So I want to welcome everyone and ASEC to this uh, seminar, knowledge exchange seminar among ASEC members. And it's a two-way street. It's not just one way from ASEC to FedMES. It's both ways. We'll all learn together in response to the 2025 Myanmar earthquake. This is our first session, and I want to welcome all of you, especially the speakers, the moderator, and the speakers who are going to be presenting, and then all the people who are attending, who are going to be participating in the interactive session immediately after each speaker. I want to introduce the FedMES Federation of Myanmar Engineering Society's president, Engineer Khin Mong Hate. And if you can say a few words, please go ahead right now.
Thank you. Okay. Well, good afternoon, good evening, and good morning to all of you joining from different parts of the world. It is a great privilege to welcome you to today's Knowledge Exchange session. Among ACECC members focused on the recovery activities following the devastating Mandalay earthquake that struck on March 28 with a magnitude of 7.7. Many of you may recall that the Federations of Myanmar Engineering Societies had the honor of hosting the 48th ACECC Executive Committee meeting at the Novotel Hotel in Yangon on April 7 and 8, just days after the earthquake. Why? We initially planned a site visit for April 9. Our priorities quickly shift. Recognizing the urgent needs, the ACECC delegates convened right here in this hall to brainstorm how best to support the recovery efforts. In that spirit of solidarity, our ACECC friends expressed the readiness to contribute not only their expertise, but also their heartfelt support. From that discussion, we launched a multi-step support process. Step 1 involved an expert team comprising specialists from Japan, Pakistan, Bangladesh, and Nepal, conducting a situational review of the affected area. Step 2 focused on developing training and technical guidance for recovery process. Although logistical challenges prevented the expert site visits, our engineers stepped up to conduct rapid assessments of the damaged buildings. Their findings were submitted to the ACECC expert team, who used them to develop today's program. This marks session 1 of our knowledge exchange series, with section 2 and session 2 and 3 to follow. Today's speakers brings a wealth of knowledge in earthquake engineering and, more importantly, hand-on experience in post-disaster recovery efforts from their home countries. I am confident we will gain valuable insights during these 2.5-hour sessions. Following the presentations, we will have a question and answer segment where I encourage all participants, whether here in person or joining online, to engage actively, share your thoughts, and raise any questions. To our esteemed speakers from Japan, Pakistan, Bangladesh, and Nepal, and to the presidents and secretaries general of ACECC, thank you sincerely for your tireless efforts in organizing this session. With that, I consider my remarks and warmly hand over to our moderator, Professor Kyoungsoo Park, Chair of ACECC's Technical Coordinating Committee. Thank you very much to you all.
Thank you, President Jae. I want to first introduce the chair of the Asian Civil Engineering Coordinating Council. Is Professor Jae-Woo Park. And by the way, I didn't introduce myself. I'm the Secretary General, Udai Singh. And so I would like, before we go to the moderator, I would like the ACECC chair, Professor Jae-Woo Park, to say a few words. Professor Park.
Good morning and good afternoon, everyone. My name is Jae-Woo Park. Even though my name is read as Kyoungsoo Park, I'm using Kyoungsoo Park's notebook. On behalf of ACECC, I want to congratulate this major event. To those of you who are in Myanmar, who may not be familiar with the ACECC, let me briefly introduce what ACECC is. ACECC is a society of civil engineering societies from 17 different countries. One of the major activities that we are doing is technical committees. We have currently 35 technical committees, and this activity is led by Technical Committee 21 and 22. They are disaster-related technical committees, and they have done very well so far. So this is, again, the combined effort by ACECC and FedMAS. So hopefully this result can benefit not only ACECC, also the FedMAS. So without further ado, I will give this microphone to Dr. Singh. Thank you.
Thank you, Prof. Park. Appreciate your comments. Now I want to introduce the ACECC Technical Coordinating Committee Chair, Professor Kyoungsoo Park. He's also from the Korean Society of Civil Engineers, and he will be moderating the session, facilitating the session. So, Professor Park, please go ahead.
Okay, all right. Well, my name is Kyoungsoo Park, and I'm the ACECC Technical Coordinate Committee Chair. So first, I'd like to thank to TC 21 and 22 chairs for the initiating and leading these knowledge transfer sessions. So, well, today we are having 4 speakers from the ACECC member societies. So let's move to our technical sessions. So first speaker is Professor Kimiro Meguro. Well, he's a member of TC22, and also he's a professor at University of Tokyo, and he's an expert on the urban earthquake disaster mitigation. So, well, Professor Meguro, so well, now the floor is yours.
I thank you very much. Can you hear me and can you see my slide?
Yes, very clearly.
Yes, okay. Hi, thank you, Chairman. I'm Kimiro Meguro. Today I'm very happy to give you some lessons that we have learned from the past earthquake disaster in the world, and also I'd like to give you some information on outline of the SATREPS project in Myanmar. Hi, this is the contents of my presentation today. There are 6. The first one is point of presentation and conclusions. Hi, I would like to say that to implement urban safety and resilience, it is important to improve not only technical issue but also social issue. To do this, the importance of academia and academic organization like us should be recognized widely from national to local governments and also the public, general public. And we should be neutral, and judgment and research results should not be influenced by the government, politicians, or some private companies. That we should be stable, sustainable to continue to produce the stable results in the long term. Among all disaster countermeasures, I will explain you detail the disaster countermeasures, but among all, the many people, especially in developing countries, believe that emergency disaster response is the most important one. But this is wrong. It is quite difficult to save people by search and rescue operation, especially by international teams. Pre-disaster countermeasures, especially damage mitigation measures, composed of structural mitigation and land use management mitigation, is the most important one for disaster reduction. However, what is more important than whether there are standards or whether they are good or bad is the creation of an environment that implements buildings to be constructed in accordance with the standards in proper area. And also, it is impossible to recover and build back better from huge disasters by only post-disaster countermeasures. We should keep our mind. Hi, the second one, outline of the SATREPS project in Myanmar. SATREPS stands for Science and Technology Research Partnership for Sustainable Development, supported by JST, Japan Science and Technology Agency, and JICA, Japan International Cooperation Agency. The purpose of our SATREPS project in Myanmar, entitled Development of a Comprehensive Disaster Resilience System and Collaboration Platform in Myanmar, is to build safe city through disaster risk assessment and through preparation. Hi, this slide shows the organizations from Japan side, also the Myanmar side. To build safer city through disaster risk assessment and through preparation, we did 2. First, assess the risk of urban disasters, earthquake, flood, and also transportation systems, and prepare for disaster in future. And second, disseminate research outcomes and contribute to the improvement of disaster response capacity throughout Asia. This shows the total picture of the project. Earthquake, transportation, flood, and cyclone. These are our target hazards. And we did a lot. We prepared the database. We monitored many data and prepared the database. And use the database, we developed a methodology to estimate or to evaluate the potential risks. And based on the analysis, we propose some system, such as land use management system or supporting system for disaster response, or near real-time flood forecasting system, these type of the one. And also we helped a lot the counterpart organization to establish research center or develop the consortium. This is to continue the activities even after this project. And as a capacity building, we have been training, and also we have established a training system, and we donated equipments, and also we gave them educational curriculums, and also we pay strong attention to let our partner organization to have the university autonomy. There are three autonomies: autonomy in the organization, autonomy in personal management, also autonomy in budget management. At the end of our project, we could have the organization and personal management, but even at the time of the end of the project, we could not get the autonomy in budget management. We installed many sensors in infrastructures, or we installed the rain gauge, or installed the many equipments and monitor the data and developed. And the right-hand side one is infrastructure management. We put the equipment to judge the damage of the infrastructures. About the detail part, I'm sorry I cannot touch today because of time limitation, but if you search through the website, you can get a lot of information of our research outcomes. Hi, next one is the mechanism of disaster and structural damage due to earthquake and the importance of disaster imagination capacity. Hi, this shows the mechanism of disaster. Normally, we are thinking that what is input, what is system, what is output. The input is a hazard, earthquake itself, ground motion itself, or cyclone itself. As a system, if you are a person who discuss only the structural damage, this system can be just a structure. But when you want to discuss the damage in general, this system is your target area's regional characteristics composed of natural environmental characteristics, also social environmental characteristics. When these two characteristics are fixed, then the next time-related factor will be important. Seasons, day of the week, and occurrence time. And as an output, some phenomena happen. But this is not only the physical phenomena, but also social phenomena. And these phenomena beyond some criteria, then for the first time, we call that phenomena as disaster or damage. And a huge disaster is the chain action. I mean, this output comes the next input. And in two domains, space and time domains, the chain action increase. So if you do not face the huge disaster, you should install some cutting system within the small range of two domains. And sometimes people are saying that the disaster is evolving. The mechanism of evolving is not the change of the input. Global warming is just an exception. Normally, we cannot touch the hazard part. As we have developed, we have changed the system, that's why the output becomes different. Disaster imagination means understanding these mechanisms and consider the season and the time. And when the hazard attack, as time goes, what happened around you? Can you imagine, well, This is the imagination, disaster imagination. We human beings, it is impossible for us to prepare well or to respond well for an unimaginable situation. That's why disaster imagination is a very key, essential, important one. Hi. Towards implementation of proper disaster countermeasures, there are three important conditions. One, know your enemy, two kinds. Second, know yourself, three kinds. And the third one is disaster imagination. The two enemy means input and output. That is hazard and disaster. And yourself, the first yourself is from the input, how to understand the output. This system should be understood. That's why yourself, first one is your regional characteristics. And second yourself is the capacity of the governments that you belong, from the national level, prefectural level, municipality. But the citizens, they do not know well about the capacity of the government. What they do is ask everything to the government. It's impossible, considering the resource and time limitations. And the third yourself means real yourself. The people who do not understand the real capacity of themselves, they do not do, even they can easily do and enlarge the damage. Okay, and the third, that's imagination. And if you satisfy all three these conditions, then you can find out and evaluate your current problems and future problems. And based on the evaluation of the results, think of measures and carry them out in proper timing. Using, this is important, using two different length rulers. One is long one is short one. Big space, big area, and long time. This is a long ruler to show the direction. But many people do not understand well what they should do concretely. So for those persons, by using the short ruler, you should explain the action and its effect. But this type of the guidance is a local maximum problem. Even you keep the local maximum problem, but sometimes you are going away from the global maximum. That's why we should keep our mind two different rulers. Hi, next one. Comprehensive disaster management system based on disaster life cycle. Hi, this shows the quite important concept. 3 pre-disaster countermeasures and 4 post-disaster countermeasures. The first one is damage mitigation. This is composed of 2 countermeasures. One is structural mitigation to increase the performance of the structure. In case of the earthquake damage, increase the seismic capacity. In case flood and tsunami, we should increase the height of the dike, levee. This is called structural mitigation. And the other one is, if you know this is a dangerous area, then authority should not give the permission to use or to construct this house here. This type of the one is called land use management mitigation. And the second, even technically possible, but it costs too much. We cannot adopt such countermeasures. In such case, we prepare something before the hazard attack, and we can reduce the affected area, or we can reduce the velocity of the negative impact propagation. That is called preparedness. Concretely, the preparation of the disaster response organization, preparation of recovery, reconstruction plan, or preparation of the manual or drills. These are the components of the preparedness. And before the hazard attack, if we can predict the hazard and give early warning, we can reduce the damage. Earthquake prediction is still quite difficult, but how about the typhoon, cyclone, tsunami? These three are called disaster countermeasures. And then hazard attack. What we should do first is assess the damage, where, what kind of, how big volume damage happened as soon as possible, as high accuracy as possible. This is damage assessment. And the next, based on the damage assessment, what we should do is sometimes we put emergency at the top, emergency disaster response. There are three purposes. One, save the people, rescue the people. Second, to prevent the secondary damage. Third, to recover the important function as soon as possible. But this does not include the recovery of the affected area itself. Therefore, recovery and reconstruction should follow. The recovery in general means recover to what it used to be. But that is not enough. Disaster, especially the big disaster, has the unique characteristics that even with or without this disaster, big disaster show the potential problems of the affected area had even before the hazard attack by shortening the time more visible. Therefore, disaster is very unfortunate event. But once disaster happens, this is the important opportunity to improve, to solve the potential problems that the affected area had. So we should improve the condition better than before. That is the concept of reconstruction, build back better. Okay? And through that comprehensive disaster management system, what we can improve our capacity. One is disaster risk reduction or disaster risk control. This is how we can reduce the damage after the hazard attack. The next one is disaster resilience improvement. This is a combined capacity. One is quick recovery capacity to what it used to be, recover to what used to be, plus capacity to build back better. When some target area had disaster risk reduction, without disaster risk reduction, damage become different, small, large. Therefore, the disaster response activities, this workload become light or heavy. Okay, and when we prepare the good disaster resilience system, then what happened? So what we should do is from the bottom worst case to the best case. Hi, now hazard attack. Then some damage happened. How big damage happened is based on the mitigation capacity and prediction and warning before the hazard attack. And some level of the damage happened. And then from this level, how to recover to what it used to be. This is a part of the disaster resilience. But this is not the whole. Plus capacity to build back better. In 2010, there was an earthquake in Haiti. That earthquake damage was beyond the country capacity of Haiti. Therefore, many other countries, international organizations come to the site and help a lot. And when the supporting organization did their best, this lead point could be shifted from this location to somewhere here, left-hand side. But they did not do. Do you know why? This is a quite important point. If they do this, the Haiti people, the time Haiti people learn what they should do to improve their disaster management capacity. That's why they established the system. Why is so many structures collapsed? And how to develop the code? How to implement the code? Why we could not respond well? What kind of organization we should prepare? What kind of training we should have? Then the lead point is shifted a bit right. But the time is going. Therefore, when even a little bit, the bottom triangle area become big. But when you do the time numerical time integration in time domain, then this plus part is quite important. Hi. Okay, this takes time. Skip. But when we think about the disaster project in the world, many projects just focus on emergency phase, but its efficiency is very small because time limitation. I will skip. If you are interested in, please give me question later. Next one, real situation. When we look over the past earthquake disasters, more than 10,000 fatalities, we could pick up 32 events. Among 32, 8 events are the collapse of masonry type of structures, and many people were killed. Upper map and bottom map. Upper one is distribution of the masonry type of structures. The bottom one is high seismicity region. Because these maps overlap each other. That's why many people are killed. And there are 3 major causes why so many people are killed. But it is quite difficult to save the people by search and rescue by international team. 2015, April 25th, there was an earthquake in Kathmandu, Nepal. And Japanese government, on the next day, April 26th, 70 specialists with most advanced equipments and rescue dogs using specially chartered airplane and dispatch the team to the Nepal. But because of the bad operation of the International Tribhuvan Airport, they are forced to go to India first and again come to the Nepal. And they started search and rescue operation from April 28th to May 8th, totally 11 days. Nearly 800 mandate activities are there. And Ministry of Foreign Affairs, they wrote on their website that for these activities, government of Nepal, Nepali people, they express their sincere appreciation. But please think about what are the real results. If you are interested in, I will explain you later. This is the statistics of the number of people who are rescued while they are alive and who are found after they are killed. By the international teams, the number of people who are saved is just 0.1% or less. This is quite difficult. This shows the Kobe case, 1995. So please don't expect that. By search and rescue, it is quite difficult to save the people, especially by the international team. Hi, the last one is some recommendations. Based on my past 35 years experiences in our field, and based on the damage site survey, I wrote some recommendations for this time affected area people. First, establishment of damage situation report. This type of the report should be prepared not only for this time, but also for the future disaster. And quick inspection damage of private buildings. This is also important to accelerate the recovery reconstruction activities. And it's better to conduct a field survey to record what happened. These data are also quite important for future disaster reduction. And mid to long-term measures, discussion for future earthquake resilient urban planning and building construction. This is quite important. And risk-sensitive land use. This is also important. Based on why the many structure collapse. From the recipient side, structure weakness. This is a problem. But from the ground motion viewpoint, the ground motion is a function of the magnitude and distance and site effect. Site effect means soil condition. Then, based on the survey of the soil conditions, we can prepare the microzonation type of the maps, and using this information well and prepare the risk-sensitive land use management. And compliance of the building code and building permit. In developing country, lack of engineers, even the people want to get the permission of the construction, they should wait for a long queue. And also, the document of the construction permission will not managed well. Therefore, sometime in future when disaster happen, it's quite difficult to trace who designed this, who gave permission this, who constructed this. This type of the systems, if you are interested in, please please ask me later. And promoting disaster risk reduction in Yangon. This is, Yangon, Nepido, Mandalay. These biggest three cities are located just beside or just on Sagaing Fault. The similar damage will be happen. So you had better pay attention. And collaboration among stakeholders are quite important. Okay, this is what I'd like to say you this time. Thank you very much for your kind attention.
All right, yeah, thank Professor Meguro. Well, I think this is very comprehensive talk on disaster management. So the floor is open for the question. So I think you guys can raise your hand or you can speak up. Let me check. Okay. Well, I have a short question. So you explained it about the disaster mechanisms, like input, and we have a system, and we have an output, right? So especially on this international cooperation, I think understanding system is also very important. And you also talked about the regional characteristics, right? So
Yes.
yeah, we are having some different reasons. So what will be the most important indicator or aspect in terms of the regional characteristics?
I cannot say this is the most. It's dependent upon the situation. If some preparedness is okay, then the most important issue become different. Therefore, it's depend upon the location.
Location.
Of course, location means the target area.
Target area. Okay. So which means like a frequency of the earthquake or magnitude of the earthquake. So that's what you're saying, or?
Yeah, that is one of them.
Okay.
But we should think about many. For example, the natural environment, as what you say, the soil condition, or the natural related one. But about the social one, this is the human related one. This is distribution of the people and population density and politics, economics, and history, education, religion, many. Because these affects the lifestyle of the people in the area. We should think about all. And then when the hazard attack, and as time goes, what really happened around you. That is a disaster imagination. We people, we cannot prepare well for unimaginable situation. We cannot respond well for an unimaginable situation. That is quite important point.
Okay, all right. Thanks for your answer. What any other questions or comment?
So please pay attention that by search and rescue, by international teams, it is quite difficult to save the people. And many projects just focus on emergency phase, spending a lot of money, but real results from the disaster management, it is quite limited. Emergency phase disaster project, the search and rescue, and the emergency supply, both of them do not contribute the disaster reduction in future. Pre-disaster countermeasure is a real key. So please understand. Otherwise, we cannot reduce the disaster. And also, once some damage level beyond the criteria, by only post-disaster countermeasures, it is impossible to recover. That is, we call national critical disaster.
Okay, all right. Thanks for the final comment. And okay, so also I just found the question Chashu, yeah.
Yes, thank you for your presentation, Professor. As for our country, Myanmar, may I ask, what is the most important aspect we should focus on in the meantime? Like, it's been 3 months after the major earthquake right now, and my question is, for current condition, what should we focus on for the recovery? Yeah, thank you.
And for new construction, first, so you should check the soil condition of the area and construct the structures following the code. Now, many people want to construct the structures, but because of the bad management or quality control, poor quality construction will be done in many locations and many structures. So it will be a negative inheritance in future. And again, the big disaster happen and attack the next generations. We should stop that cycle.
Okay.
Thank you, Professor. Thank you.
All right. Thank you. So then we'll thank again, and then now let's move to the second speaker by Dr. Sarosh Lodi. So he's a former vice chancellor of NED University of Engineering and Technology. So he is going to present on seismic retrofit of non-engineering buildings. So let's welcome Dr. Lodi. Dr. Lodi is in here. It seems, okay, Dr. Lodi. Well, I think he is not available right now. So then, well, then maybe we can move to the third speaker. Okay, so to continue our workshop. So then our third speaker is a Dr. Shafiul Islam. So he is a public works department of Bangladesh. So his presentation is a visual rating method for seismic prioritization. So Dr. Islam, so yeah, I think I can see you. Okay, now floor is yours.
Can you see my slides?
Yes, I can see your slide.
Okay. Is it okay? The mode?
Yes, perfect.
Oh, this one. Now is okay?
Well, we can see two. You need
Two
to.
slides.
Yeah, two slides.
Oh, I see this one. What do you want?
Now it's
Now
okay.
you can see one
Yes.
one single slide, right?
Yes.
Okay, thank you. So thank you very much, respected chairperson of this session. This is Mohd Shafiul Islam, executive engineer. I'm working in Public Works Department in Bangladesh. So I'd like to thanks ASEC and MES, Fed MES for arranging such knowledge sharing session. This is very important for us, especially who are working in this sector, especially earthquake resistance or disaster management prevention. And actually, my presentation is title is Visual Rating Method for Seismic Prioritization for Detailed Evaluation of RC Buildings. Actually, this presentation is kind of before earthquake. So we need to prepare to reduce damage or reduce casualty. That's why we need to do conduct seismic evaluation of existing building. So this is kind of a little bit different from the like a post earthquake disaster mitigation or something like that. But this is very useful tools for identifying the vulnerable buildings. So uh, there is past damaging earthquake like Nepal earthquake 2015 and Ecuador earthquake 2016 and also recent Myanmar earthquake 2025. So this earthquake exhibits that there is many seismically vulnerable buildings in the world, especially in developing countries, and those buildings are kind of similar types of buildings, masonry infill RC frame structure. And we need to some strategy to how to reduce the seismic damage or something like that. That's why in Bangladesh also there is not much. Recently, there is no earthquake, but the neighbor country the exhibit that there will be some possibility to earthquake in Bangladesh also. So if there is happen, then what will it will be big disaster because there is big chunk of building. You see huge building stock in Dhaka city, and this is very urgent to seismic evaluation. And but problem is how to manage those huge stock building because we don't have expert, we don't have budget and also time. So that's why we developed a rapid evaluation method, and also we set some priority for detailed evaluation. So there is those limitations and those difficulty and there is many problem in Bangladesh for buildings. And based on this, so we have about 12 to 13 years long technical cooperation project with JICA, like CNCRP, uh, like uh, like CNCRP, BSPP, SATREPS sweep project, and UBSP project. So this project is running now, UBSP, but we just finished recent SATREPS sweep projects. So the outcomes of SATREPS sweep projects, I will talk about a little bit the outcomes of the SATREPS sweep projects. And one of outcome is and here we developed some technical manuals like visual rating manuals, seismic evaluation manuals, and seismic retrofit manuals. These also based on the Japanese seismic evaluation standard, and this is the outcomes from the SATREP sweep projects. And today in my presentation, I'll talk about only VR manual, VR manual, visual rating method. So actually, before development, the visual rating method, we studied the existing method in the world, RBS method, FEMA method, Turkish method, and also other method like Indian method or something like that. But we try to apply this method in our country to understand the applicability and effectiveness. But since in Bangladesh there is only one type of structure, is very common like RC masonry with masonry infield RC buildings. That's why there is some limitation is found. So here I'm talking about just only FEMA P154 method, and here FEMA method considers only one score for RC masonry type building, RC with masonry infield type building, and here also some score modifier, and they consider also some data sheet, and here the only one score, but uh, if we consider the applicative effectiveness in our country, so if we consider two building like model building A, model building B, and if you see this both building is six-story building, and here model building A is span length low and is a span length is high, and here column size is high and here is column size low. But FEMA consider both two buildings are same basic score. But if we consider seismic capacity of these two buildings, this is not same. So this is the actually the effectiveness in Bangladesh. Actually, we have only these types of structure system. That's why we cannot apply FEMA method directly in our country. That's why we developed the method like a visual rating method we developed in our country through the SATREPS projects. So now I'm going to talk about the theoretical background of this method, visual rating method. And here the basic idea actually comes from the Shiga map. And Professor Shiga, he considers two parameters, small parameter like average shear stress in RC column and RC wall and cross-section area of RC wall. And he applied this concept in Tokachi Oki earthquake and Miyagi Oki earthquake 1978. And he found he plot this map, and here y x direction is wall ratio, and y the vertical direction is the average shear stress ratio. And he found that this is two parameter can easily identify the vulnerable building and damaged building, non-damaged building. So therefore, if we consider this idea and concept in our country, but in Japan, the RC beam column frame type and concrete wall type is very common. And in Bangladesh, like in Bangladesh, Nepal, and Myanmar, also we have these types of buildings like masonry infill RC buildings. So how we can apply this Shiga map concepts in our country? So this is the point. So we try to understand to the seismic capacity, we have three types of lateral element like RC column, masonry infill wall, and RC wall. So if we sum of all column strength, masonry infill strength, and RC wall strength, then we can understand the seismic capacity. And if we divide the building weight, then we can find this equation comes from here. We can find the column area ratio, masonry infill ratio, and RC wall ratio. So here, the column area divided by number of the floor area is called the column area ratio, and also infill wall area and uh, the floor area is also masonry infill ratio, and RC wall ratio also similar. So this concept to understand to estimate the seismic capacity index, we applied this idea in the past earthquake damage database. Here we consider is 53, and this is the survey data sheet they consider during the investigation after earthquake. And most of the buildings 2 to 3 story building, and those buildings are actually school buildings. And we found this data from this data center hub. And here we calculate the seismic capacity index, the equation in x direction and y direction, and we can see this seismic capacity index has a very close relationship with the damaged building. So this can clearly identify the damaged building, severely damaged building with the safe building. But if we want to apply this idea in existing building, we need architectural drawing and structural drawing. But in our country, in Bangladesh, we most of the existing building, the architectural drawing and structural drawing is not available. So in that case, we need we developed the visual method based on this idea and concept. VR method is like simplified way for prediction of seismic capacity using the column area, masonry infill area, and number of story. And the main purpose of this method is to calculate the visual index (IVR) and to categorize the building A, B, C, D based on the visual index (IVR). And now I'll talk about how to calculate this IVR. Here, IVR is nothing but seismic capacity index, and I already showed this equation in previous slides. And here we converted these equations to here, this visual index. And in the following slide, I will talk about the how to calculate this column area ratio to simplified column area ratio, and simplified masonry infill ratio, and simplified concrete wall area ratio. And since this is visual investigation, so we consider some UAT index like plan UAT and vertical UAT, and also time index based on the deterioration and year of construction, building age. And first of all, the simplified column ratio. Simplified column ratio can be calculated by using very simple two parameter like average column size, average span length. So if we have this this building, you can see if we check one or two or three column, then we can understand the average column size of this building. And also, if we check one or two span length, then we can understand the average span length. So by using very simple parameter, the average column size, average span length, we can understand the simplified column area ratio. Simplified masonry infill ratio also can be estimated by using masonry infill thickness, average span length, and masonry infill ratio. And here, masonry infill ratio is the number of masonry infill panel, here the total number of span in the direction. So if you see in this here, we have to choose only the solid infill. The masonry infill with the opening is not considered in this study. So in this case, if you see in X direction, there is only two solid infill, and the number of span is 16. So therefore 2 by 16. And on the other hand, the Y direction 3 by 15. And here we consider 2 by 16. And similarly, RC wall ratio also we can calculate by using this the three simple parameter like RC wall thickness, average span length, and RC wall ratio. So since this method is visual is screening, so we can during the investigation we can know these types of irregularity. So if you see, this is the horizontal irregularity aspect ratio, and that's why in Nepal earthquake there is some damage due to this types of irregularity, and also the vertical irregularity. This open ground floor is very common in Bangladesh and also other developing countries, and these types of damage is happened during the earthquake. And that's why we considered some penalty factor for this irregularity. And there's some basic assumptions for the material properties of we and also judgment criteria. Also, we based on the score, we set some criteria like at least to highest priority for detailed evaluation. So this is the theory and background of this method. And now I will talk about some application of this visual rating method in existing building. So here we applied 1020 building in Bangladesh by the SATREPS projects supported by JICA. And here this area we choose, and this is the building aerial view. And this is the typical building we surveyed in Bangladesh. And here, if you see, most of the buildings, 3 to 6 to 8 buildings, and in Bangladesh, after 2006, 63% building, and 91% building is residential. And we during the survey, we use this VR data sheet. This is proposed based on the study and research, and we applied this data sheet, and then we estimated the IVR of those value, and then we can see the about 30% building is under 0.2, less than 0.2. That is very vulnerable buildings, and need immediate detailed evaluation. And also we category here, the about 30% building is CGE category. And also we compared with the detailed evaluation of this IVR value, and this is a IS2 Japanese seismic evaluation standard. And here also IVR, and we can see that IVR index also has very good correlation with the seismic index detailed evaluation. And also other visual skill method we also compared, because initially I showed the FEMA method, and also we applied this FEMA method and also VR method in Taiwan database, and we can see there is very good correlation with the visual index with the damage building, but there is a relationship, but not like that good because FEMA score considers a single score for the masonry infill RC buildings. And here, based on the theory background and also application, so we prepared a manual, like a handouts manual to easy application for the professional engineer, so that they can apply the existing building. So this manual has 4 chapters. Chapter 1 is introduction. Chapter 2 is theoretical background development procedure. Chapter 3 is application procedure, and also Chapter 4 is judgment criteria for the priority settings. And there is some example also to understand the application procedure. And here the summary of this presentation. So a visual rating method is proposed based on the detailed evaluation and Japanese standard, and also this semester seismic capacity for the higher level evaluation. And also this method can be used in other countries like Nepal and also Myanmar, considering the local material strength and also local seismicity. And actually this method is very useful, and also it's possible the in also Myanmar building, because in Myanmar building, what I showed in the figure in the picture, the masonry infill RC building, so which is also common in Bangladesh. So we can also apply this method in Myanmar by throwing some training and also workshop in future, so that we can understand the at least the vulnerable buildings, how many vulnerable buildings is there. So that's all my presentation. Thank you very much. So if you have any questions or comments, it will be appreciable.
Yeah, I think this is very interesting presentation. It's presented a very simple method to quantify the damage of the buildings. which also can be potentially utilized in Myanmar as well. All right, so the floor is open for the questions. So then, let me first ask one question. You at the end, you also mentioned that the method can be potentially utilized in other country as well. So then, my question is, what will be the potential challenges? Like, what will be the limitation? So, well, I'm not saying your method is bad. I'm trying to understand what will be the limitation.
Thank you, Sensei, for a very good question. Actually, this method is applicable for master infill RC buildings. So if we apply this method other country like Nepal or Myanmar, so we need to think about the material properties only, because in Bangladesh we consider column strength or master infill strength. So if we know the master infill strength or RC column strength in the other country, then it is very important, easy to apply in other country. This is the major limitations actually. But it is possible to apply, reconsidering the material.
Mm. Okay. Right. Okay. I think Shafiul also raised the hand. Okay.
Yeah, thank you for your presentation. And I'm currently helping some homeowners for doing seismic evaluation after the earthquake. And so, may I ask, is it possible to get the reference via manual, PWD manual? Can you give the reference for us? Yes. Thank you.
Of course, it is very appreciated. So actually, in last the 10 years project, we have developed those idea concept tools. We are using Bangladesh, and if it is very appreciated if you apply this idea concept in your country. So I'll share our technical manual to you, and then you can apply. And if necessary, I can give short training how to apply in field. Also, and also it's online training also possible to learn about the application procedure of this manual, of this method. Thank you.
Yeah, thank you, sir. Thank you.
Yeah, I think someone wants to ask questions, maybe, or any other questions or comment? Well, if not, well, I thank Dr. Islam, and then now let's going back to the second speaker. I just noticed that Dr. Lodi is online, so let me introduce the second speaker. So Dr. Sarosh Lodi. So he is a former vice chancellor of NED University of Engineering and Technology from Pakistan. So, he is going to give a presentation on seismic retrofit of non-engineering buildings. Okay, so Dr. Lodi. So,
Sir, thank you very much. I hope you can hear me. First of all,
yes.
I would like to extend my very sincere apologies because I miscalculated the time. As a result, I joined in late. So my very, very sincere apologies. I thought we are ahead, 1.5 hours ahead rather than Myanmar being an hour. So somebody prompted, and I really would like to apologize for missing out the first two wonderful presentations. Sir, I have about 100 slides. Obviously, I won't be able to cover them in the next 20-25 minutes, but I will share the slides for future reference for our engineers. So, sir, the part of the world that we are living in, unfortunately, has a plenty of non-engineered structures. Because of so many reasons that I don't want to go into, but despite of the fact that the countries in South Asia have their building codes, have but the enforcement at times is not as ideal as it should be, and as a result, people violate and build structures which are not compliant with the codes, and especially in the rural areas where where people can build the way they want to. So this is the whole idea that I would like to cover some of the basic retrofitting strategies that we have employed in Pakistan, and as a result, we have increased the seismic strength. So there are several reasons for making a decision on the retrofit. Obviously, in our case, the is the desired seismic resistant, as pointed out on point number 3. And as a result, the objective is to resist the earthquakes, either to resist the earthquakes without any damage, or to resist moderate size earthquake with non-structural damages. And even if it's a very severe earthquake, even if there are major damages, then we make sure that the building doesn't collapse and cause casualties and injuries to the residents and the people around this. So that's the objective of the retrofit here. Obviously, there are so many things that needs to be retrofitted, but my focus today are the buildings only. And then obviously, when we are talking about buildings retrofit, then the principal idea in the buildings which needs to be retrofit is that they, number one, lack lateral resistance. They cannot withstand the lateral shaking of the ground. And on top of it, they lack ductility. And ductility is when there is a post-plastic deformation capabilities, unfortunately. And because of that, these are the principal weaknesses that we experience here. Now, one of the things that we have to be very careful is to decide whether to retrofit or rebuild the structure. It all depends on the remaining life and the expected cost. And the experience that comes out of it is obviously the importance, the quality of construction, the expected life, and the level of intervention. And on the right, on the abscissa, you can see the remaining life of the building, and on the vertical axis, we are talking about the percentage of the resistance here. And anything which has less than 50 years of remaining life, I don't think it is worth retrofitting. However, this is what the basically a decision-making principle that we have, that if the structure is new, it can survive longer period of time. We must make investments to make sure that they remain operational and functional. That is why the investment levels are higher. You can see up to 94% of the investment here. Now the strategies of retrofit is that we can either use the lateral strength or lateral stiffness or ductility, or a combination of these factors here. If we want to increase the strength here, you can see the difference between the two sketches, that there are bands at the sill and the window level, sill level, and the roof level. And if these bends are provided, that increases the strength of the material because this acts as a box. Similarly, if it is a building like this and we would like to add stiffness also, introduction of a shear wall is something that increases the stiffness also. And then in order to increase ductility, there are measures that we can take here. So this is the flow diagram which helps the engineers to decide whether there is a retrofit needed or not. I will not go into the details, but leave it for you to go into the details here. Now we have to have the understanding of the performance level. There are structures which are retrofitted for immediate occupancy, or life safety, or collapse prevention. These are the three performance levels on which the building codes are now working. And this is what we have in mind, that whether we would like to retrofit the structure for essential structures which are used as shelters, or essential facilities where we want to have more retrofit so that there is no structural damage and minor non-structural damages could be repaired and could be used immediately after an earthquake. And then the life safety means that there can be structural damages, but these damages can be repaired later on. And then there is a retrofit level where we don't want the structure to collapse on people. So we put a minimum retrofit so that it doesn't collapse immediately, and it gives time and warning to the people to evacuate here. So I've already explained this thing. Now, there are two types of strategies. Either we globally strengthen the structure, or we locally strengthen the structure at different component level. I will skip these slides and I'll go directly to different methods of retrofit, especially for masonry and adobe structures which are non-engineered. So for example, I'll come up here. There is a tendency to make long unsupported walls, and as a result, they collapse out of plane. And I'm sure in Myanmar, I've seen a lot of failures in Pakistan after these kind of earthquakes. These kind of buildings are normally available in the rural area. So the best is to put cross walls around here so that this as a box and the unsupported length of the wall. If you go into the details, they put all here, only by putting a wall is not going to provide the surface, so there must be a connection. And you can see the details of the connection that are provided here, that this is the existing wall, this is the new wall to be provided, and then you have to have anchorage either in form of reinforcement or any other thing, so that the two walls are connected together and they act as one. Or we can provide bracings from outside. Once again, the idea is to reduce the unsupported length, and in this way, the inside function and functionality of the hall is not disturbed, but the outer buttresses can be then designed or can be put in a manner that they don't look very awkward architecturally. But that once again increases the lateral stiffness because the unsupported length is reduced. And once again, there must be a connection between the buttresses and the existing wall here. Now, this is another example of thatched kind of buildings, which are huts here, and we can provide cross bracings. And on one side where there is no door, we can provide cross bracings in terms of bamboo or anything available. And in this, they can put a door so that people can go in and out, and still we can have bracings, and that increases lateral stiffness tremendously because these diagonal members provide significant axial stiffness to resist the lateral forces. Once again, this is something that has been experienced in all over the world very, very effectively, and that is to put the bands outside the bands at the floor level, at different floor levels, and they could be either wire mesh or ferrocement bands, which can help people. And they can be done it's a very cost-effective method. And the whole idea is to make the box together so that the stiffness of the box acts rather than the walls that we have here. And instead of walls acting independently, the whole box acts like this, and that increases the overall moment of inertia and eventually the stiffness. I'll show you some of the videos later on if I have time. And obviously, we can put reinforcement also in unreinforced masonry walls so that the vertical and horizontal bars can be placed here. And they also provide significant axial resistance. And these are the details of wall strengthening that can be done here. Similarly, for roof and column, there can be bolting of the rafter, because normally in rural areas, what we do is we put the roof on top of the wall without having any connection. And that obviously the diaphragm can slide easily. And when it slides easily, this can fall on people's head. And that is why if a connection like this and like this is provided, that makes the wall and the diaphragm act together. And these are once again the details of the things that I'm talking about, that at the beam column joints, at the junctions where the walls are, the two walls are meeting, there can be anchorages provided in terms of reinforcement, and the horizontal and the vertical details are here. Similarly, the vertical section is here. That these kind of reinforcement can be drilled and then can be filled with grout, and that provides the anchorage to improve the stiffness of the walls here. This is yet another example that instead of having horizontal reinforcement drilled, we can have diagonal reinforcement. This gives us more length to be drilled in, and obviously more axial stiffness. And this is called stitching of the walls. When two orthogonal walls are meeting, this is how the stitching of the walls could be done. Then in terms of existing columns, we can put the jacketing along the column. So there is an existing column already here, And we put reinforcement, the vertical reinforcement you can see in terms of circles, along with a stirrup or a ring, and then put concrete around it. That also adds a lot of value. And this is what my friend, I'm sure, Shafiul Islam also shown in one of his presentations. Then, depending on the availability of different material, of these kind of diagonal and vertical steel plates can be anchored into the walls. Once again, it's an outer frame which provide lateral resistance. Similarly, these details can also be provided here. And now I'll go to some other retrofitting strategies, and that is, if you see here the foundation, we can add foundation so that the soil problems could be handled here, and the dowels are drilled into existing foundations, and then the concrete is poured here, and then the masonry can be placed once again so that it increases the size of the foundation. Once again, the walls, which are unreinforced masonry walls, they can be, we can put wire reinforcement on the outer side and then plaster it so that it is anchored. But once again, it has to be anchored either into existing columns or into the adjacent walls to provide a proper anchorage, and similarly in the beams above and below. And anchorage is extremely important. Diagonal bracing, I'm talking about now the reinforced frames here. You can provide diagonal bracings where the angle sections are anchored into the beam column junctions and the foundation junctions. And then with the help of a gusset plate, which is welded here, the diagonal bracings can be bolted so that it provides the lateral resistance which is needed. Similarly, I've talked about buttresses also. So for frame structure, we can put buttresses, and obviously we need additional foundation to add buttresses so that the buttresses can be supported by the ground. We can have wing walls here inside. Instead of having the entire reinforced concrete frame, we can have small portions of reinforced concrete depending on the need of the performance of the structure. Similarly, these are the details of the anchorages that I was showing, that in the diagonal, in the beam column junction, this is the beam, this is the column, you anchor the angle or the plates here with the gusset plate, and the gusset plate is then either welded or bolted with these diagonal members. And these are different kind of arrangements and details that can be done very, very easily. This is a drilled section. This is the anchored from the outer side, and on and on. Now, all these methods have certain advantages and certain disadvantages. So the retrofit strategies, if you add an additional infill wall, it increases the lateral stiffness of the structure and can support the lateral loads. However, premature failure can happen at the junctions here. This is a low-cost, less destructive method. It doesn't increase the ductility, but it increases the weight. Additional shear wall similarly has increased lateral resistance, may increase ductility also, but that needs a lot of integration with the wall. It is a very disruptive method, but this is also, so you have to decide the flow diagram that I'd shown you. You have to decide looking at the flow diagram, that what are the things that one can afford. Similarly, additional bracings, additional frames, they have their own merits and demerits. Now, if you're talking about the local retrofitting strategies, the columns that I've shown you here, that can be jacketed here. The important thing to note here are these splices. These splices have to be at the center of the column length rather than near the joints, because at the joints we have the maximum moments. So that is why at the center span of at the center of the height of the column, these moments, the seismic moments are smaller. So the splicing must be done in this manner. Another strategy is if we want to strengthen the beams, the beam is already there. The reinforcement is passed through the beam, anchored into the upper floor, and then the sides are then cast with the concrete here. So these are the different strategies in which the anchorage could be done. So you can see here the stirrup is a U-shaped stirrup, where this is a complete rectangular stirrup going into all sizes of the things here. We can put screed on top of it in order to hide all these things. Similarly, this is another anchor bolt method which can be used for column jacketing. Rather than jacketing the entire column, we can put angle sections on all the four corners, and then these angle sections are then put with the laces, and these lace bracings could be horizontal, they could be diagonal, so that the edges can perform the confinement effect in the column here. I will, these are the, once again, the details that I'm repeating here. They are the local level retrofitting strategies. Once again, it is a U-shaped clip. These are different kind of octagonal and rectangular, square reinforcements that can be done here. I will so one of the strategies that is adopted here, obviously this is a little more expensive field, but then the fiber reinforced concrete, fiber reinforced plastic straps are also provided at the beam column junction to ensure the strength is increased. Remember, this doesn't increase ductility, but it increases strength significantly because of the two reasons. One is the confinement effect itself, and the other is the strength of the FRP wraps that are there. And FRP wraps can be provided in different manners. This is a typical beam column junction. So FRP wraps can be provided in this manner, it can be provided in this manner, or in this manner, depending on which of the structural element needs to be strengthened more. This is how the foundations can be additional. These are bridge foundations that can be there, and they can help improve the foundation performance. And once again, there are merits and demerits to everything. So when you do the concrete jacketing, it increases the fractal strength and the shear strength and the ductility. It is easy to analyze. However, the member sizes are increased, and because of that, obviously, it may not look acceptable from the architectural point of view as well as on the usage here. Similarly, steel jacketing has certain advantages and disadvantages, and it is up to the structural engineer's judgment to decide which of the method is more appropriate to use. Now, I will show you that different kind of buildings under different performances. So this is, I don't know whether I'll be able to, I don't know, the video is not running, but if you look at this room is a block masonry typical room which has no reinforcement, and it was tested at the shake table. Unfortunately, the video is not running, so I can't show you the performance here. Once again, this is another example of a school which was made out of stone masonry, unreinforced stone masonry, which was retrofitted by my team and myself. This was up in the hills of the northern areas of Pakistan, and this is a typical building structure. It has classrooms here, a classroom here, and a classroom here, and they were nothing but stone masonry and a truss on top of it. This is how the school look like. You can see here that the school has undergone damage. These are the stone that had fallen, and you can see the rubble here. And this is the kind of masonry that is used in this stone. Absolutely non-engineered stone masonry here. So what we did, I will skip through these slides. What we did, that we took metal strips and placed them horizontally and vertically on inside and the outside faces of all the walls. So they are going all around outside and they're going all around inside, and the outside and inside plates are then connected through a pin. So a pin is drilled first, and then it is welded to this plate and this plate here. So they're all connected. So it is providing confinement, and it is also providing electrical resistance. And then later on top of that surface, a wire mesh was anchored. And then the wire mesh, once placed here, it was plastered. You can see that this wall was badly damaged. But after plaster, it looks like this. So there is hardly anything which is visible from the architectural point of view. So this is the original building. This is how we have stripped off the plaster. And after the retrofit, the school looked like this. and this remained functional, and we had done the computer analysis. This is another building which was on the other side of the country, but once again in the highly seismic area, and you can see that the same strategy was adopted of putting strips and then wire meshing and then plastering them here. You can see that the pin is being welded, and this also provided the lateral. The final thing that came out was look like this from inside and outside. So architecturally, it was nothing was significantly changed, and it has increased the significant performance. This is another school in the city of Murree, up in the northern side of Pakistan. And you can see that I was there without a beard. I was a relatively younger man at that time. And this was the school that was retrofitted. And once again, the retrofitting, the same strategy was followed. Then an adobe structure, we have a plenty of adobe structures. And then we have built a small 1/3 scale model, and then we did testing on a shake table. And this was how 1/3 model was made by the local masons, made out of adobe. And I hope that I'll be able to run the. I'm sorry, I'm not able to run the video. Oh, I'm so sorry, but this was the testing done here. And if you see, the strategy was very simple. Wire mesh at the roof level, wire mesh at the sill level. And this was going all around from outside and all around from inside. And then the bamboo strips were placed, and the wire mesh and the bamboo strips were tied together using a plastic fishing string, the string that you use to catch the fish, and they were tied together, and the testing was done. I'm so sorry. Why? I don't know why it is not, the video is not running. It was running yesterday. Anyway, so I wanted to show you that it performed extremely well because of this small retrofit. Then there's another example of stone masonry. I hope this runs. No, it's not running either. So if you look at this thing, this was a block masonry structure, and the plastic wrapping, if you look at the plastic wrapping strips that are used to wrap the boxes, we've used them in the vertical direction as well as the horizontal direction. And at the junction, we have put in the nails. And this was done from inside and outside. I'm so sorry, the video should have been running, but for whatever reasons, it's not. None of the video is running. So you can see that, even though it was shaped very strongly, but there was damage also. But the damage was not enough for the structure to collapse. And I'm talking about creating an acceleration of 1.5 G, which is a very, very high ground acceleration. This yet another house. Once again, it has you can see the plaster, but you can see the cracks in the plaster, and this is where bamboo strips were placed in the horizontal and the vertical direction, and as a result, this has provided significant resistance. This was a traditional house which is called Hunza Ha, and it is made out of timber and adobe, and so it was also retrofitted in a similar manner. The other thing that can be possible is confined masonry. And confined masonry is that you put structural elements, so you put the walls first, and then you put the structural elements. And there is no shuttering between the wall and the structural elements. And when you pour the concrete and the wall, they become connected together. This is the example once again. And this confined masonry also increases the strength significantly. So these are some of the examples that shake table test that we have done. And you can see that there is I wish I could see the video. That would have meant a lot for you to understand. And this is once again the same video. Unfortunately, videos are not working here. And coming back to what I had seen here, and I'll be done in another few minutes, if I may take another few minutes. So these are some of the typical buildings damages that I've seen here. There are two things that are eminent from the collapse of this building, all these buildings. Once again, number one, there was this soft story And this has created, because there was no confinement around it, and that was providing as a soft story, and as a result, these columns have crashed in shear. All we had to do is to put masonry and a little bit of strapping around, and this building could have been saved. And I'm talking about a very insignificant increase in the cost. Similarly, if you look at these things here, most of the failure are because of unreinforced masonry or poor detailing. You can see here the detailing is missing, and that has caused the damage here. This is unreinforced masonry walls which has collapsed. So, and once again, this is a soft story underneath which has caused the collapse. These are typical diagonal cracks in the buildings, and this happens only because the masonry has to be reinforced. These are some of the buildings that I have taken out from the reports that I have received from our colleagues from MES. I would like to thank all of you, and I hope that this presentation is useful. Once again, I'll share the presentation with our colleagues in MES for future reference. And I would like to thank you once again. And along with my thank you, I would like to apologize once again for my late entry. It was only because I thought we are ahead of time rather than our friends in Myanmar. Sir.
All right, thank you, Dr. Lodi. Well, I think it's a very informative talk while sharing, let's say, retrofitting technique in terms of global and local retrofitting, and also as well as your actual experiences. I think it's a wonderful presentation. All right, so then now the floor is open for the questions.
Hello.
Yes, please.
Thank you. Thank you. I have one question to Dr. Lodi. Thank you for your presentation, especially on the confining and the ductiling and the soft story of the damage that you have observed. I was just wondering how we can confine that wall, especially you are talking about the wall confinement. So how can we do that, especially when there is a lot of projections? So that's my question to you.
If I understand your question properly, then you're talking about the confined masonry idea, which was the last thing. Confined basically primarily is that you make the wall first, whether you put reinforcement or not is something else, and then you make the reinforcement of the column, but on the sides, on the larger sides, which are parallel to the wall. So you provide shuttering. You don't provide shuttering between the masonry and the column. And then you pour the column. So when you pour the column, the concrete actually goes into the fissures of the masonry also. And that provides that connection which is needed. And this also confines the masonry, so the masonry cannot move independently. The problem is that we build our columns first and then put the masonry. So there is no connection except for a little bit of friction, and that causes the walls to collapse and fall. But if you provide an anchorage, whether through a mechanical anchorage or through confined masonry, this improves the chances, or this reduces the chances of failure.
Thank you. Yeah, that's the always we say in paper, but in the reality, in practical way, so many of the columns are constructed earlier, and then we do the masonry work later. And also at this stage in the modern world, now people are doing a lot of projections. We go out of the column and do the freestanding walls. So that is the biggest challenge that is facing in Bhutan. So I was just wondering how we can confine that.
Sir, when we are building in seismically active areas, we have to avoid large projections, because we have talked about the damage to the buildings only, but there are so many non-structural components that can cause damage and cause casualties and can injure people. So our architects, I don't know how many architects are present today, but our architects must also be brought in confidence, when they design these buildings, they should understand the mechanics of earthquakes, so that they don't design things in a manner where these projections are vulnerable and they are liable to fail. So, it's not about a structural engineering. It's about a combination of structure and architectural architects, so that we don't get to this thing. Unfortunately, at times the homeowners, the building owners, sir, ji, and the building owners, they tend to make the beautiful buildings more beautiful, and because of that, we tend to overdo things. So we have to control this tendency. You cannot retrofit these projections. The only thing is to avoid them.
Okay. All right. So then there's another question from Shafiul.
Thank you so much for your insightful presentation, Doctor. I would like to ask the real world condition that I'm facing now. There is a big two-story RC building. The building area is over 11,000 square feet. And that, I think the performance of that building and the previous earthquake was maybe life safety level. When I go for inspection for that building, the structure members are damaged quite to quite extent. Like for those kind of building, may I ask what is the best approach for retrofitting? Should we do the restoration first, or should we go directly for the retrofitting? Although that building has not proper load part, it was amazing that it could sustain the damage under the previous earthquake. So my question is, should we do restoration first, or and then the retrofitting, or should we do the retrofitting directly? Thank you.
There's no doubt that we should do the retrofitting first, because if you do the refurbishment and then you have to go back for the retrofitting, then you have to break things again. Now, when you go to retrofitting, what strategy would you follow? It depends on the kind of failure. And the kind of failure, the whole idea is that the building should be designed with weak beams and strong columns. The idea is that even if the beam fails or undergo extensive damage, the columns should remain undamaged or relatively less damaged. So the strong column and weak beam, strong column concept must be kept in mind. I don't know what kind of damage has taken place, but if I were you, I will go for a retrofitting and then decide whether I would like to retrofit the members locally, or do I have to put a retrofit globally as well. And if it has to be global, so the members which have damaged have to be retrofitted without any doubt. Then after retrofit, we decide that whether, and as you said, there is no complete load path. So we have to complete the load path by providing the structural components in such a way that in future, because now some of the components will be weaker than the others. So now you have to, the second thing is to provide the load path and then see whether the whole frame acts together or not. If it doesn't, then you have to confine it either using bands or some other things so that the whole confinement in the box is there. So, we have to apply 3 levels of strategies. Number 1, retrofit the local structural members with a lot of importance to the columns, and then improving the overall integrity and the performance of the structure and completing the load path. Thank you.
All right.
Thank you so much, Doctor. Thank you.
Yeah.
Only one more question for me. Thank you so much, Dr. Lodi. I'm Amon from FatMass. Can I ask you something about the concrete jacketing? So I just want to know that is there any limitation or criteria between the concrete grade or maybe the compressive strength of the repairing concrete or grouting cement and the existing concrete grade? Is there
Right.
any option or? Yeah,
okay.
because normally we do the concrete jacketing, right? So we use the repair concrete or repair mortar or like the non-strength rod or something like this. So the strength between the newly concrete and the original concrete grade is quite different. So is it possible to use it, or maybe the new concrete should be not too much difference grade with the original one? Can you please suggest me?
Thank you. The first question is that the existing concrete, how much are we sure about its existing strength? Because the damage, it is already damaged and it has cracked. So whatever the initial strength was is lost. So I would not rely on the existing strength of the concrete. And if I'm jacketing, for instance, I will design the jacket in such a manner, assuming that the concrete inside the core is not functioning. Because we cannot rely on a structural component which is already cracked. Even if it is micro cracking and you can't see them, it will be very difficult to make sure that the cracking doesn't take place. So my advice would be that we design the jacket in such a manner that the entire load is resisted by the jacket, not by the core. Even though the core will be there, this will provide us some additional capacity. But in my design, I would not consider it.
Understand. Thank you so much.
All right. Yeah. Thank Dr. Lodi again. Yeah.
So before my session ends, once again, I'm terribly sorry for messing up things. I'm so sorry. I'm feeling embarrassed.
No, it's okay. All right. Yeah. So then let's move to the fourth speaker, Dr. Youb Raz Paudyal. So he is a senior division engineer at the Ministry of Urban Development, Government of Nepal. So I think he is going to share the experiences on the associated with the 2015 Kolkata earthquake of Nepal. All right. Yeah. Dr. Paudyal.
Thank you. Thank you, Professor Park. Can you see my slides?
Yes, I can see your
Thank you.
slide.
Thank you so much. Thank you, Professor Park and the Professor Singh and the team for providing me this opportunity to share my learning experiences after the 2015 Gorkha earthquake in Nepal. So title itself, the lesson learned from the reconstruction of the houses after 2015 Gorkha earthquake in Nepal. So I'm Ibrahim Paudyal. I'm working in the Ministry of Urban Development, Government Nepal. I was intensively involved for the reconstruction of the houses and the school building after the earthquake in Nepal in 2015. So my flow of presentation will be this loss and damage by the 2015 earthquake, what are the major challenges and issues that we encounter, and what are the strategies that we adopted, and what are the lessons learned from that recovery process. So in fact, in 2015, 25th April 2015 at 11:56 a.m., the 7.8 magnitude earthquake occurred in Nepal. The epicenter is 78 kilometers northwest from the Kathmandu Valley. And around 9,000 people lost their lives, and around 800,000 houses were damaged. And it's around $6.6 billion we lost, and it comes around 30% of the total GDP of Nepal. So, and we can say, unfortunately, we can say it's a lucky the earthquake was not occurred at nighttime and school hours. So if that was occurred at nighttime and school hours, the devastation could be more bigger than the current one. So you can see the peak ground acceleration value it's around less than 200 gal. And we know that in 1934 we had the earthquake that was the PJ value around 350 gal. So even though the acceleration value is low and we can see the magnitude also 7.8, we losses many buildings, many people who were lost their lives. So from the figure we can see that even the modern kind of buildings, the RCC buildings, Professor Lodi just the previously mentioned about the soft study failure, and even though the cement-based building also were collapsed very heavily because of those soft study failure basically in the district headquarters and the Katun Valley as well. And most of the hilly settlement where the heat very hardly, and our headquarters mostly located in the mostly in the ridge line, and that we can see the many topographical effects there, and many non-engineered building, and also some the engineered building also collapsed by this earthquake on those locations. And the severe impact on the rural houses and the educational and also the health facilities, health building as well. That was because of the weak masonry construction and also, as mentioned before, the poor ductile detailing. And if we see the causes and losses of waste, we know that in this part of the world, like in Nepal, we have a very weak physical infrastructures and also poor design, and actually construction techniques and construction practices. We learn from the ancestor, the modern technique, and also in the practices still, need to be, the lot of work need to be done on that part in larger part of our areas. And our building regulations and building laws, building code, yes, we formulated, but not updated, not implemented well. Some of the rural areas, some of the urban centers we implemented, but in the most of our rural areas is still to be implemented at that time as well. That this is the main causes that we have felt. And yes, we had this Natural Calamity Act 1982, though that was focused most on the response and the very limited preparedness activities, not the focus most on the mitigation part, based in the planning and also implementing of the code. So we now, after this earthquake, recently we in 2017 we approved this Disaster Risk Reduction and Management Act, and that tell a little bit about the holistic approach of the disaster risk management, and it tell more about the mitigation part as well, and the roles and responsibility of the different organizations for the mitigation of the disasters. So that was one of the lagging that we felt, and also absence of the disaster risk reduction plan at the local levels, and the disaster risk reduction was not mainstream in the development activities that we that we felt that these are the main causes of losses from this earthquake. Yeah, during the recovery process, we felt many challenges. We observed many challenges and issues during the recovery process. As we know that we started from the scratch. We didn't have the very good organizations. To talk about those the recovery process. We didn't have the institutional memory. It was the 1934. There was a very huge earthquake, but we didn't had such kind of the institutions to look after those kind of recovery process, and we didn't have the institutional setup. After the earthquake, we set up the National Reconstruction Authority, but before that we didn't have such kind of institutions that can lead the reconstruction and recovery activities, and of course in the central level and also local level as well. And as I talked before, legal framework, policy, codes, and guidelines that were not developed, were not updated, and coordination among the different institutions, mechanisms were not done. So these are the coordination mechanisms. The developing the coordination mechanisms for the recovery is very, very important. That's why we faces many challenges. How to coordinate the different actors. many actors, they interested for the to support to us after the any kind of disasters, like our in 2015. So how to coordinate those kind of how to build up these mechanisms, that we faced a lot of challenges. And in operational level, of course, damage assessment and need identification was the key for the recovery process. So of course, we felt at the beginning, this is a very new thing for us, and damage assessment, need identification, post-disaster need assessment, post-disaster need recovery framework, the need to be developed, and a lot of resources, the required, the financial, manpower, the labors, skills. So a lot of things that we need to be, the many people, many, the areas, they need their recovery first. They need the support at first. They need they felt urgency everywhere. So these are the resources challenges that we felt at the beginning. As you know that we have the very geographically challenging areas. Is a very accessibility is a bigger challenge for us. Most of the locations are in the hill areas. So we also that kind of challenge, how to mobilize our resources there, and how to mobilize our masons, how to mobilize our the technical expertise that they are on those locations. And at the first time we felt this scale of that the disaster. So scope and scale is very huge at that time. So we need many designs, many technical the expertise, and somewhere we need the new design, new buildings. Somewhere we need to go for the retrofittings. Somewhere we need to go for the emergency response. Yeah, that kind of challenge that we have faced, and then how to maintain the qualities. So these are the major challenges in operational level. And that's why we, at the beginning, the good thing is that we, thanks to the different development partners, support hands, they supported very well. And we started with the post-disaster need assessment. We did the post-disaster need assessment and recovery framework we developed as well. And we, the massive, the damage assessment and vulnerability assessment, the movement we did through our, engineering societies. We took a support from the different development partners, like in the World Bank, the structure integrity and damage assessment tool we developed and then implemented. That helped us to, calculate how much damage was done, was happened, and then, the recovery, developing the recovery plan, and also the investment plan, and then the priority investment plan. So these, the assessment results help us very much. And we set up this very special instrument, the National Reconstruction Authority, and in the central level. And in central level also, we set up the central level project implementation unit. In the district level, we set up the district implementation unit. So that is a very good channel flow from the central level to the district level and the local level as well. And we develop the different policy guidelines, to engage the different actors, the multi-stakeholder engagement, the kind of things we develop. And one of the beautiful things, from the government side, we develop the one-door policies. So that helps a lot. Who can we welcome all the actors who wants to support for us, but need to be channelized from the one-door system. If he wants to, any the organizations want to support, he need to follow our rules and regulations. You need to follow the basically the technical aspect and financial aspects. So we make such kind of arrangement that helps a lot. And of course we establish the different policies and guidelines, like the design guidelines, and also in the somehow we develop some research and development for the remote schools, and also the SMC school management committees, and also community-based reconstruction as well. So we develop the different kind of modular design as well. So I'll talk later on those aspects. And yes, of course, that it was earthquake happened in the May 2015. But before that, March 2015, the third UN World Conference, the Sendai Framework Action in the approved, and also I don't know, we may be the first in the countries who apply that the carry on those approved principle, Build Back Better principles. And from the development partner side and the government partner, we took at one principle that for the recovery process. So that gives up the holistic planning and implementation is a very, very important things. And then we develop our, the guidelines and also our designs in line with that Build Back Better principles from the Sendai frame of actions. So, and the large kind of, the human resource development activities we conducted, large, we mobilized, the more than 5,000 technical persons for the recovery process. We provide the technical trainings, not only the technical training, but also the inspection trainings as well. So this kind of activity we have been done, and not only the technical person, but also we provide the training to the local people as well, community as well, social mobilizer as well. So how to coordinate the community, the interest with the central government and also the local government. So this kind of mechanisms we developed. For that we organize the massive, the training and mason training as well. And we apply one of the beautiful things is that this decentralized approach of the responsibility. So engagement role from central government, what are the clear, the roles and regulations, roles and the responsibilities, local government, development partners, and the NGOs and communities as well. So, and coordination, monitoring, evaluation mechanisms we develop from the central level. So these are the something, that we did. That's why the results, I think were in front of us. And for the private housing constructions, because, we are in the developing world, so we are developing country. So underdeveloped country even, and so we took the owner build system. So house owner need to build their houses by themselves. That helps to minimize the cost, and that helps to maximize the ownership and sustainabilities and strengthen the community capacity to other resilience. So this, the owner build system help a lot, the mobilizing the community for the reconstruction of their damaged houses by themselves. For that, we, the three, the pillar that we implement together. One is the training to the communities, and about those requirement of the government guidelines, and also the disaster, the resiliency, or the earthquake resilient houses need to be constructed. So, and second thing, we mobilize the huge number of engineers, technical person to supervise the construction and the recommendation of the grants. And also we have those, as I mentioned already, the massive mason training. The trained mason we the use for the construction houses. So eventually, these three pillars work together, and that helps for safer and our communities. I think the working with the communities, collaborating with the communities, coordination with the communities from the technical to the community and central level to the local level, that helps a lot for the building of the disaster resilient society. So these three things work together, and then we successfully implemented for the reconstruction of the private houses after this earthquake. And some strategy, as I mentioned before, we provide only just a very, as like a seed money, 300,000 Nepalese rupees. It's around 3,000 US dollar, as in a 3 installment. In each and every installment, for example, once the agreement done with the beneficiaries, and then we provide just the 50,000 Nepalese rupees. And once they construct up to the plinth level, and then engineer will take all those details, and then if it is compliance with the building code, it complies with our standard, then engineer recommend for the second tranche, second installment, around 150,000 rupees. And then the community go for the further construction, and then they complete it up the roof level, and then only we provide this remaining 100,000. So total 3 installment, only provide to them after the inspection, after doing the inspection from the engineers only. So and we make the very formal mechanisms to provide this grant as well, directly through the bank. So each and every beneficiary, they need to open the bank account, and so we directly provide the amount through the bank in their own the bank account. So that helps a lot to trust with the central government, and then to the local government and to the community. So house owner then, and another things, we develop different kind of modular design but house owners can prepare their own design as well as per their requirements. But all those design need to be, fulfill the minimum requirement as prescribed by our, the guidelines, and also the Nepal National Building Code. And then if it is the complex kind of building, for example, step footing, they need to check with the structural engineer. And technical supervision, as I mentioned, recommendation of the grant installation through the engineers. House owner need to use the skilled and trained masons as far as possible for the construction of the houses. These are the, the design catalog we developed, in September 2015, the first catalog that consists of the 17, the modular design. A second volume we developed in 2017 that was, the based on different, the different, the support hand that, that came up with the different alternative materials. So we also, prepare to support on those parts as well in the second volume. So in total, 32 modular design in 2 volumes we prepared to support for these housing reconstructions. So in between the mass rallies, different kind of training to the house owners, and the enrollment camp for the participation agreement and community meetings. So that helped a lot to educate the people, to educate in the communities, the requirement of the earthquake resilient houses, and then in the construction of the building as soon as possible. So, and mason training is one of the major activities we conducted. Last, the kind of mason training, the is more than 100,000 masons, we prepared from this movement. We took the support from the government Nepal, of course, and also World Bank and government Japan through the JICA, UNDP, USAID, and different, the UNDP, different international NGOs and INGOs supported very well for this movement. So 7 days training as a refresher training for the existing masons, and 50 days training for the new mason to prepare the new masons. And these mason training also monitor through our, the engineers, and then they need to certify each and every masons, and then, provide the certified for those masons as well. So as far as possible, we try to, enhance the capacity of the local masons, and then so that they can be the very good, the actor, to support for the community houses, or the individual private houses buildings during the reconstructions. So another one of the very important things that we have done, the community mobilization programs. This is the one of the very important achievement, one of the that helps us to communicate the technical expertise with the locals, because sometimes as an engineer we talk many things like retrofitting, like the different collapse system, different effects, from the technical point of view. Sometimes we train to the community, we try to communicate with the communities, but the community people do not understand. So we need to prepare that one mechanisms that those who can understood the feelings, engineers, the feeling and engineering knowledge somehow, and the local knowledge as well. So we developed in every communities, we developed this community-based reconstruction committee, and that consists of around 5 to 7 or 9 members from the community. We provide them, and we took them as a leader, to their own community. So we provide the training to them about the earthquake, how to build the earthquake resilient houses from the technical persons. And second thing, those committee will, train to the local community, and then share the importance of the earthquake resilient houses and how they can achieve, they can get the grants from the governments. What are the provisions they need to, make with the government systems to get the grants, and then how they can communicate with the technical person. So these kind of things they can communicate with the community people. And thirdly, we create the mobile masons. The mobile masons are those masons who understood some technical knowledge, who can understand some, we can say some knowledge of the engineering knowledge as well, who can read some drawings as well, some technical terms, and he can build the walls as well. For example, the engineer, if you ask the engineer cannot build the wall. He can just observe, monitor the wall, whether it is straight or not, what are the quality of mortar, what is the quality of the bricks, but if you ask the engineer to build the walls, it is not possible. So we prepared one systems who can understand the engineering knowledge and also the local knowledge, so that in every communities we prepared the mobile masons. He can move from one place to another place, one community to another communities, to train to check their local working labels. Means the local masons who the work for building up some of the beneficiary houses. He is going to train. He is going to check. He's showing. He demonstrated whether their the working level is okay or not. So because the engineering, the engineer time is very precious, or it's the time to time he cannot go every houses. So we developed these mobile masons that help a lot, to make the compliance of the all those the reconstruction houses as per our guidelines and building codes. So this that helps to transfer the engineering knowledge to the community, community. So that helps a lot for rapid, the fast recovery of the houses with the technical standard. So we did a lot of collaboration and coordination with the development partners and also international NGOs and NGOs, and because sometimes they prepare the designs, need to be accepted, need to be approved from the government side, and also we collaborate for the supervision of the construction, and we collaborate with the awareness building, community mobilizations, and we coordinate with the masons training as well. We coordinate for this printing of the materials as well. It is a huge, large scale of materials that we need at that time. So, however, once they supervise, they recommend, and our government engineer need to check for the the distributions. So that kind of collaboration, we did. You can see that some model houses they built and they show in the community with the earthquake resilient elements. So this kind of campaign we did during our recovery process. So what are the lessons that we learned? This thing is in the institutional organizational level. The clear responsibility authority is very, very important. That helps for the decision making, prompt in the decision making, and the development plan and program is very important, because without assessment, without damage assessment, without vulnerability assessment, it's really really possible to develop the investment plan and the priority investment plan, priority area to work. So that's very, very important. And the resource management, financial and human resource, because a lot of the manpower we need. So, but where we need to mobilize first, that is very important. And transparency and accountability, it's a very, very, very important thing, because to communicate with the communities, to make them the government is working for them. And so we as I mentioned before, we created the individual bank account, and there is no the misuse of their fund. We convinced to them, because in central government provided 300,000 rupees for them for the building their houses, and then they will get through their bank account. Nobody would involve in between. So only they need to build their houses as per the standard, as per the guidelines that we develop the system. So that build up some trust between the government and the communities. So communication coordination channel we develop, and planning and monitoring at that time. After that, the COVID-19 also affected very much. After this earthquake as well, we developed some web-based platform to monitoring some construction, reporting of the progress from the district level to the central level as well. So in operational level, code and ethics, code and guidelines is very, very instrumental for the effective management. Need-based infrastructure for the implement local expert and manpower. Responsible local management and responsible local committee is very, very important. We need to make them more responsible to organize, to manage their recovery activities. And of course, the governments from central level and the district level can provide the technical and the other support as well. But we need to make them responsible to build their houses by themselves. You are the responsible person to build your houses with earthquake resilience. So this kind of things we need to provide to them. And web-based platform, of course, as I mentioned before, capacity development, engineers is a very, very important. It is not only one time to time, refresher training, for example, the retrofitting training, capacity building, quite different than the new constructions. For the mason training, for the masonry structure, low strength masonry, is quite different than the RCCs. And so steel structure and wooden structure building, they want to build in the community, but we need to provide them the training from the engineer to the engineer. So, and the masons, and also the somehow to communication channel, to build the communication channel to the social mobilizer as well. So disaster sensitive designs also enhance the local knowledge on DRR. So in conclusions, I just pointed out 6 points here. I have many things I can explore. I can, can present many things what we learned from this recovery process. But here, the integrated recovery policy and institutions is very important, and assessment based in the investment plan, and also the implementation plan is very, very important. National codes, standard designs, and guidelines are instrumental for resiliency and build back better. And local technology, we need to, this is the opportunity for us to upgrade our local technology, because in the local, the local people and local masons, local, even in the engineer, they learn from their ancestors, learn from the practice only. But how to enhance those local technologies from the engineering point of view? This is very good opportunities. As Professor Lodi mentioned about the low strength masonry, how to retrofit the low strength masoneries. There may not have the scientific analysis there, but we have those kind of things, techniques from the beginning, but we need to just improve it based on our modern science. So that is one of the important thing that we can do from this, the recovery process. And the quality enhancement for the capacity buildings is a very, very important. We can develop in this part of the world, like now, we can took the many virtual platform to monitor the sites, to monitor our engineer activities, to monitor our contractor activities in the field level, to monitor our community activities in the field level as well. And lastly, the community participation, community involvement, community engagement. It's instrumental. It's very, very important. And we need to work with the community. We need to convince, we need to build the trust with them, because they need the urgent, they feel the urgency. Yes, thank you so much. These are my conclusions for this today presentation. If you have any questions, let me know. I'll try to respond your queries. Thank you. Thank you so much. Thank you.
All right. Thank you again. All right. So now the floor is open for the question. Any questions or comments? So then I have a very short question. So then your conclusion slide, and community-based cooperation is also important. So since this is a somehow international workshop, so could you share some experiences or related to international cooperation?
Yeah, of course. Actually, for the community-based construction is a very unique in the developing world, basically for countries like Nepal, Myanmar, and Pakistan, even India as well. So we work with the Japan granted program, and somehow the loan project as well with Japanese experts. And we did some research with them, how to mobilize the communities. As I mentioned in my slide, the community-based, the community mobilization program, we piloted in one of the areas, and that helps a lot, to fast recovery and with the standard. So, and then we replicate to the other part of our country as well. affected areas. So, and one point, and second part, we in Pakistan we tested for the school construction the low strength masonry. For example, for the school case, we tested, we piloted and this stone masonry building, and we tested in the Pakistan. And later on, it's not much implemented for the school case, but it must implemented for our housing reconstruction. So these are the partnership that we have built up during the recovery process.
Okay, all right. Thank you for your answer. And next question will be by Dr. Bashir.
Thank you, Dr. Park. I think, first of all, I would like to congratulate ACECC for a wonderful initiative along with the MES Myanmar. I think probably this is the first time, please correct me if I'm not wrong, that we have arranged such a seminar through ACECC. Dr. Udai, you will correct me if I'm not wrong. And
I will correct you the second time.
And I think that it should not. It is just a humble beginning, and now we'll start doing this thing, because this is what ACECC is meant for, to support the communities, to support the member nations, how to develop strategies for effective use of civil engineering in respective areas, not only in buildings, but also in infrastructure, in water retaining structures and all those things, which are vulnerable to not only earthquakes, but also floods, cyclone, and all those things. So I think it's a very humble beginning from ACECC, and I also take this opportunity to thank all the speakers, Professor Kimiro, Dr. Sarosh, Shafiul Islam, and Dr. Youb for excellent presentation, probably very relevant to the Myanmar, what we heard during our visit 2 months back in Myanmar. And I hope that the recovery is going on a fast track, and probably whatever have been suggested, prescribed, may be used in the activities being carried out at Myanmar. So all in all, thank you for, and again, a very good participants. I can see it was around 105, 106. So a lot of participants, especially from Myanmar. So very excellent effort from FEDMAS for this particular thing. So, and also thanks to the TCC chair for organizing this activity. Thank you very much.
All right. Yeah.
Professor Park, if I may. Yeah, one comment on Engineer Bashir. Actually, this is the second time. Right after the 2015 earthquake, you were there when we had, I think the next year, the 2016, we had a very limited seminar, organized by TC21 in Kathmandu. So there was some effect, but this one, I think we are hoping to do a wider array of knowledge sharing in areas, and this is the first session. So I want to make an announcement. The second session is already been scheduled for the Wednesday, the 30th of July 30th, Wednesday. And we will cover other topics like you mentioned, Engineer Bashir. We'll hopefully cover topics that were not covered in this session one. And then we hope to have a third session a month or so later. So we'll announce that later on. But please mark your calendars. ACECC and FED-MES will work together and put together the program in the next couple of weeks or so, and we will publicize it through another flyer. So that's coming. But thank you very much. And Professor Park, please go ahead.
Yeah. Thank you. Well, I think yes.
Professor Park, yeah, just I want to mention here is that from TC21, Professor Iswatari, and yes, San, and also we, the team, we 2 times we visited in Nepal. We work together, the how to, this community mobilization program, that can be replicated. We publish some of the, our papers as well, related with this community mobilization program. And we try to, the work together and how to replicate in other part of the world as well. So let us work together, because we have learned a lot from from this, the earthquake related with the community mobilizations. Thank you. Thank you.
All right, thank you. So I think today's workshop is pretty much well organized. Where we covered the disaster management system, and also how to assess the damaged structure, and also how to retrofitting the structure. And finally, we also had a chance to share the experiences in terms of from the government sector. So I thank to all the presenters and ACECC members. And also I really hope that this workshop will be helpful for the fast recovery of the Myanmar earthquake. And as the Dr. Udai mentioned, this workshop will continue. So please join the workshop in the second workshop. And thank you for all your participation. And this will finishes today's workshop. All right. Thank you all.
Thank you.
Thank you very much.
Thank you. Thank you.
Thank you very much.
Thank you so much. Bye-bye.
Bye-bye.
Thank you.
Bye-bye. Thank you very much. Bye-bye.